Welcome to Web Development Lesson 4.1. In this video, we're going to introduce a new programming concept called decisions, which are extremely important to programming because it allows a program to decide what the next possible outcome is and control the flow of a program. In doing so, we're going to explore comparative operators, which allow us to structure a question for the computer to answer to determine what should happen next. We'll see that these questions turn into something called a Boolean expression. So let's get to it. All right, so in our first example, we're going to try to make a decision as to whether the person's passing or failing. So we pretty much got the user interface here, and we have some JavaScript that's already associated with this particular scenario. So I would definitely suggest before you embark in any kind of decision making, make sure that the fundamental program is working. So let's just test this out. So it's 100, 90, and 80. And we can see here we get a nice little message that reiterates the grades that we put in, as well as the average, which is 90. Let's test it with a failing grade. So let's say 60, 50, and 40. Again, just to ensure that we're getting the full range of grades. So now what we want to do is empower the program to be able to tell the user whether they're passing or failing. So for that, let's introduce a variable, status, and let's just set it equal to nothing. Now our job is to change that word status depending on whether the average is passing or not. In all languages, you will use what's called an if statement to empower the program to make a decision on its own. The only thing that really changes between programming language is the syntax. You'll notice here that I introduced some parentheses. Now these parentheses are not about a function. It's not mathematical. It's the way if statements are written in JavaScript. So just realize when you create a decision in JavaScript, you must put the parentheses next and then specify a condition. Or another way of thinking, a question that needs to be answered. So I'm going to put this here as a comment. Is the average greater than or equal to 65? So that's the question we're trying to ask. Well, that's what the question we want the computer to answer. So we can do that by writing a condition that says if average is greater than or equal to 65. Okay, so that is how you write a decision. Now, if it happens to be the case that that the average is greater than or equal to 65, let's set the status equal to passing. And let's improve our output by displaying that status. And let's just give it a try. So let's do our 100, 90, and 80. And that gives us an average of 90, which is passing. So the reason this displays is because the answer to our question, is the average greater than or equal to 65? This turns out to be true because 90 is greater than or equal to 65. This question, this condition, can also be thought of, or let me not say thought of, it is what's called a Boolean expression. So let me display what that looks like here. So I know this might seem a little awkward to do, but you can actually use the console log to display a full expression. So let's run our program again, and I want you to pay attention down here. So I'm going to do the same thing with the 100, the 90, and the 80, and we get the word passing, but look at what's being displayed down here. That means that this condition, this Boolean expression, turned out to be true. So you could think of true as answering the question that we're asking as yes, or let me put in a failing grade now. So let's say 50 and 20. It gives us an average of 53. And notice that we now have a Boolean expression of false. Now, sometimes when students are first introduced to decisions, they think that when the condition doesn't come back positive as a true statement, or we don't answer the question yes, that's an error. It's not an error. What it does is that it simply decides, okay, we didn't meet our condition, we didn't answer our question correctly, so I'm just not going to do this code, and then continue on with the rest of this program. So don't think of an expression, a Boolean expression that turns out to be false as an error. It just tells the computer that whatever outcome you have wanted to happen with the decision isn't going to happen. All right, so let's improve on this a little, because notice how the person's failing, but they don't actually get the word failing, and you can kind of see from the code, we didn't write anything for failing. So we can address a different question, and let me do this different. Let me take that out. Is the average less than 65? So let's structure that decision. So that's going to be a average less than 65, and if it is, we'll simply specify the status as failing. All right, so let's run the program again. Now, I highly suggest that anytime you introduce new code that you test the old code out to make sure that we are still getting passing. And now let's check for the failing. And now we do see the word failing come out. So we can see that for the first decision, the answer turns out to be no, a false value here. But for the second if statement, this turns out to be true. 56.666 is less than 65, so status becomes failing. Now, before I move on to another structure for our decision, I want to review this part right here. These are called comparative operators. These are key in being able to structure your question. Now, there's various types of comparative operators. There's ones to check that something is equal to, which is two equal signs. And students sometimes have a hard time with that one because we already used the one equal sign as an assignment operator. But if you want to make a decision, you got to use two equal signs. If you want to check for something not to be equal to, well, that's the exclamation point, not equal. And then you got the ones that we've seen already, which is the greater than, less than, greater than or equal to, less than or equal to. Again, with practice, you'll naturally be able to pick up how to structure your conditions so they become Boolean expressions. Because as you can see, at some point, these expressions have to evaluate to either true or false. All right, so let's go back to our problem here, our scenario, and I want to show you a better way of doing this. So in conjunction with an if statement, we could add something that's called else. And how an else statement works is, if the condition turns out false. Okay, so this is a nice mechanism that if our question that we're asking isn't affirmed, we don't get a yes out of it, our expression doesn't turn out to be true, we can specify what to happen when it's false instead of creating a whole different decision. So let's just run this again to make sure that it works. So we still get the passing. Now we got to check out the failing. So we'll say just simply put 0 and 0 here. And notice we get the failing as well. So using the else statement, we still are able to get the same outcome as two separate if statements. Again, in some cases, it's cleaner to write your decision as an if-else when you have two possible outcomes. In other cases, you have to specify separate if statements, depending on what your scenario is. All right, so for the next example, I want to show you how we can not necessarily always work with numbers. So I'm going to comment out the first example. And let's introduce the second one, which is the idea of an access code. So the computer is going to ask us for a code, and then we're simply going to specify back to the program that, whether you have access granted or not. So I already got a little bit of that shell program written up here. I just kind of hit it way down there. So we get the code from the user. Notice I don't do a parse int on it. Again, because there's no need for us to, we're not doing any kind of math with the number, with whatever gets entered in. What we are going to do is we are going to make a decision. So there's also no mathematical operation involved here. So we can go straight to our decision. And let's phrase the question first. Is the code equal to, let's say, 1A, B2. For whatever reason, let's say that's our secret access code. So now let's write our decision. So we're going to say if code is equal to, so two equal signs here, 1A, B2, then we can simply specify some kind of a message. And I'll tell you, I'm going to follow the same formula like I did before, and I'll create a variable called status. I'll set it equal to nothing. And then in here, I'll simply set status equal to access granted. But now, based off what we just learned in the previous example, we can write an else statement because you know what? Maybe they don't get the right access code. And at that point, we can state that the status should be access denied. Now, one thing to remember, you might do a lot of great work programming, but if you don't display something back to the user, they're going to think that the program is broke. So at this point, we're simply going to display status, and let's give it a try. All right, so let's enter a code of 1, 2, 3, 4, 5, which should give us an access denied. And now let's do 1A, B2. Access granted. Okay, so in this last example, you can see, decisions aren't always about numerical comparisons. They can be about comparing strings, text information. All right, so let's go back to our presentation and review what we've done in this video. So in this video of lesson 4.1, we've introduced a new concept called decisions. Decisions empower a program to decide what should happen next, whether it's a different calculation, a different display of information. Again, it's up to you, and you'll see that as the lessons progress, you'll be doing more with decisions. The key to a decision is the condition, which answers a question. And we can use comparative operators such as equal to, less than, greater than to answer those questions. Ultimately, that condition is a Boolean expression that has to evaluate to true or false. So hopefully you're excited about being able to make your programs think on their own, and enjoy.